This is Pluto, the ninth planet from the Sun, or at least that's what we were taught in school. Then, in 2006, scientists decided Pluto wasn't a planet anymore, and quietly told us to forget about it. They underestimated us, and they underestimated Pluto. Luckily, a bold team of scientists wasn't about to let Pluto's reputation die. That same year, NASA launched New Horizons, a probe set to study Pluto up close for the first time. What they found was astonishing. We had all been wrong. Pluto isn't just a frozen dot in the distance, one of the most vibrant and mysterious worlds in our solar system. So why was Pluto demoted in the first place? It wasn't some grand conspiracy. It had more to do with evolving definitions of what makes a planet. This debate has been ongoing for centuries. Back in the 1800s, when modern astronomy was booming, there were nearly 20 planets. Every new moon or large asteroid discovered was often labeled a planet. Eventually, stricter criteria became necessary. Fast forward to 1930. Clyde Tombaugh, a self-taught astronomer and telescope maker, was tasked with searching for a hypothetical planet X, believed to be influencing the orbits of Neptune and Uranus. After 10 months of meticulous observation, he spotted a faint, slowly moving light beyond Neptune. He had found a new world. Pluto. At the time, the rules for planethood were simple. An object had to orbit the sun, so moons didn't count, and it had to be unique in its location, unlike clusters of asteroids. Pluto met both criteria and was officially classified as the ninth planet. But as our understanding of the solar system deepened, we realized Pluto was far more complex than anyone imagined. Though it lost its planet title, Pluto's mystery, beauty, and scientific value have never diminished. Thanks to New Horizons, we now see Pluto not as a demoted planet, but as a fascinating world brimming with surprises. Unfortunately for Pluto, things changed in 2006. Scientists updated the planetary definition. To be a planet, an object must have enough mass to clear its orbit of other similarly sized objects, a cosmic vacuum cleaner dominating its neighborhood. Pluto doesn't do that. Instead, Pluto drifts through a crowded region known as the Kuiper Belt, the solar system's outer junkyard, filled with leftover ice, rock, and debris that never formed into planets. And Pluto isn't even the biggest object there. It's just the brightest, which is why it is spotted first. In fact, Pluto is one of the most reflective objects in the solar system. Only Venus and Jupiter exceed it, thanks to their thick cloud layers. From afar, Pluto looks bigger than it really is. Pluto also has a wild orbit. Unlike most planets, which travel in a flat circular plane, Pluto's path is a dramatic oval that sometimes brings it closer to the Sun than Neptune, almost on par with Uranus, and tilted 17 relative to the solar plane. So it spends most of its orbit above or below the ecliptic. Not that we notice quickly. It takes Pluto 248 years to complete a single orbit. All this makes Pluto not a planet, but definitely weird, and weird can be fascinating. That's why engineers at Johns Hopkins University built the New Horizons probe, to see just how strange this distant world could be. Distance was the main challenge. Pluto is extremely far away, and scientists didn't want to wait centuries for a flyby. So they designed New Horizons, a lightweight 1,000-pound probe, and launched it on the most powerful rocket available at the time, an Atlas V with 5 additional boosters, producing roughly 2 million pounds of thrust. This was enough to send New Horizons hurtling toward Pluto at unprecedented speed, beginning a journey that would finally reveal the true nature of this icy, mysterious world. New Horizons left Earth in a hurry. In just 9 hours, it had already passed the Moon, about 10 times faster than the Apollo missions. After a year in space, the probe approached Jupiter, which wasn't just a pit stop. NASA used the giant planet to test New Horizons' imaging system. capturing stunning photos of Jupiter and its moons, including an erupting volcano on Io. More importantly, Jupiter's immense gravity acted as a slingshot, boosting New Horizons' speed on its way to Pluto. Even with this gravity assist, the journey through the outer solar system took another 8 years. By 2015, New Horizons was finally close enough to begin imaging Pluto. Two bright points of light gradually grew larger: Pluto and its largest moon, Charon. Pluto and Charon have an extraordinary relationship. Charon is roughly half the size of Pluto and orbits extremely close, just under 20,000 kilometers away. For comparison, our moon orbits Earth at nearly 400,000 kilometers. This proximity creates a unique double tidal lock. One side of Charon always faces Pluto, and one side of Pluto always faces Charon. If you stood on Pluto's far side, you'd never see Charon. On the near side, it would hang in the same spot in the sky forever, because Charon is so massive relative to Pluto. They don't technically orbit Pluto. Instead, they orbit a point in space between them, which at first glance looks like they're circling a mini black hole, but it's just gravity at work. Once New Horizons got even closer, it began sending the first real images of Pluto's surface, and the results were breathtaking. Forget a dull, icy blue ball. Pluto is a riot of color. Deep reds, pale blues, whites, yellows, and burnt oranges. The most famous feature? A giant pale heart shape formed by low-lying ice plains. The side facing New Horizons, known as Sputnik Planitia, is smooth and flat, roughly the size of Texas. Remarkably, it's free of asteroid impact craters, suggesting the surface is geologically active. Constantly reshaped dot at the top edge of the heart. Intricate lines appear, glacial flows moving down from highland mountains into the frozen plains. These patterns reveal that Pluto's ice isn't like Earth's. It behaves in ways unique to this frigid world, where temperatures drop to minus 229 degrees Celsius, minus 380 degrees Fahrenheit. Far from being inert and lifeless, Pluto's surface is dynamic, colorful, and full of surprises. Pluto is so cold that water ice is too hard and brittle to form moving glaciers. Instead, the surface is dominated by nitrogen ice. On Earth, nitrogen makes up most of the air you breathe, and in liquid form, it freezes anything on contact. On Pluto, temperatures are so extreme that nitrogen itself is solid. Zooming into Sputnik Planitia, you see intricate polygon-shaped lines in the ice. These are created by convection currents. Heat rising from Pluto's core melts the ice, and in the vacuum of space, the nitrogen doesn't become liquid. Instead, it undergoes sublimation, turning directly from solid to gas. This process forms a thin, layered atmosphere over Pluto, which extends high into space, thanks to the dwarf planet's weak gravity. The surface pressure is roughly 1/1,000,000th of Earth's, at least when Pluto is deep in the Kuiper belt. However, Pluto's elliptical orbit brings it closer to the Sun at times. When this happens, sublimation intensifies, thickening the atmosphere to about 1/4 of Earth's pressure, roughly 3 times that of Mars. At that point, conditions might even allow liquid nitrogen to exist on the surface. One of Pluto's most striking features is the deep, blood-red region along the left side of the heart, known as Cthulhu macula, technically Bellin Regio. Its red hue comes from tholins, organic compounds formed when sunlight irradiates methane and carbon dioxide in Pluto's atmosphere. These molecules clump together, turn red, and fall like radioactive snow, spreading across the surface and mixing with flowing ice and gases. Pluto also boasts ice volcanoes, the most impressive of which is Right Mons, towering 5 kilometers high and spanning 150 kilometers wide. It erupts a slushy mixture of water and methane. This isn't an ancient relic. The volcano shows almost no impact craters, indicating it's still geologically active. constantly reshaping Pluto's surface over cosmic timescales. Pluto, once thought to be a cold, lifeless rock at the edge of the solar system, is in fact dynamic, colorful, and mysterious. A world of ice, gas, and potentially liquid processes that continues to surprise us with every observation. So, how often does Right Mongs erupt? Maybe every few million years, but where does its icy slush come from? This is where Pluto gets truly mysterious. You may have learned that Pluto is just a frozen ball of ice, but New Horizons prove otherwise. Beneath its surface, Pluto likely harbors a thick layer of liquid water, kept from freezing by a still warm core. This structure is similar to the icy moons of gas giants, like Europa around Jupiter or Titan around Saturn, where subsurface oceans are heated by the gravity of their massive parent planets. Pluto has no nearby giant to warm it, yet it retains heat and enigma. Early in the solar system, everything was hot and chaotic, but smaller, distant objects like Pluto should have cooled long ago. Somehow, it hasn't. Enter Charon. Pluto's largest moon may explain much of this strangeness. Because Pluto and Charon are so close in size, it's unlikely Charon was simply captured. The leading theory: they collided billions of years ago. Instead of shattering or merging, they ended up in a locked gravitational dance, with the energy from that ancient impact still influencing Pluto today. Interestingly, the famous heart-shaped region lies on the side opposite Charon, which is probably no coincidence. Even the red tholin deposits on Charon may come from Pluto. Violent cryovolcano eruptions on Pluto can eject particles that escape its weak gravity and harshly eventually settle on Charon's surface, especially near its poles. New Horizons is still exploring uncharted territory, uncovering mysteries that may take decades to fully understand, but that's a story for another time.